December 8, 1941, the day after Pearl Harbor smoke still drifted across Oahu. Black plumes rising over the wrecks of battleships and hangars. The sound of hammers and cutting torches echoed through the Navy Yard. But inside the Bureau of Yards and Docks, a different kind of crisis was unfolding. Charts spread across long oak tables showed not just Hawaii, but the entire Pacific theater from Alaska down to Australia. The distances were staggering, thousands of miles of open ocean dotted with coral atolls, volcanic ridges and jungles that swallowed men whole. The United States Navy had ships, submarines, and aircraft, but no way to build anything once they arrived. There were no docks, no roads, no airfields, no shelters. The war was about to be fought in places that barely existed on maps, and someone had to make them livable. At 0800 hours, Captain Ben Moriel, chief of the Bureau of Yards and Docks, stared at a report typed hastily overnight. It described the state of American bases in the Pacific. The figures were catastrophic. Coral islands with no fresh water, coastlines without harbors, mountains too steep for runways. Engineers on Wake Island had tried to level ground using hand tools and dynamite. It took 6 weeks to flatten a few hundred yards. At that rate, constructing a single bomber strip in the Solomons would take half a year, and the war might be lost long before then. Moriel read the final paragraph aloud to his staff. "Our problem is not the enemy's guns, but the terrain itself." The room fell silent. They all knew the truth. The Japanese weren't the only obstacle. Geography was. By noon, telegrams were flying from Washington to Peoria, Illinois to San Francisco, to small manufacturing towns across the Midwest. The message was simple and desperate. The Navy needs machines that can move mountains. The War Department's supply officers began drafting requisitions for heavy earth-moving equipment. But the numbers didn't make sense before the war. The United States military owned fewer than 200 bulldozers in total, most of them obsolete construction models. The nation's road builders had more heavy machinery than the entire armed forces combined. America could build battleships faster than it could clear a jungle. In Peoria, a young engineer named Clarence Peterson walked the floor of the Caterpillar Tractor Company plant, surrounded by the roar of diesel engines and the clang of steel tracks. He had been designing agricultural tractors for a decade. But now, military officers were appearing at his drafting table, asking questions about torque and towing capacity. The company's flagship model, the Caterpillar D7, had been designed for farmers and road crews, not for war, but its combination of power and simplicity caught the Navy's attention. Peterson remembered the day a commander in khaki stood beside a half-assembled tractor and asked, "Can it survive salt water?" He'd laughed not for long. "Sir," the commander replied, "then make it so." Within weeks, Caterpillar engineers were rewriting manuals, sealing gearboxes, adding filters, reinforcing radiators. They coated every bolt with corrosion-resistant compounds. They designed special waterproofed magnetos and fuel lines to keep the engines running. Even when waves broke over the tracks, the D7 evolved from a construction tool into a machine ready for the Pacific's brutality. Orders poured in faster than the company could fill them. The Navy's Bureau of Ships wanted thousands, not hundreds of bulldozers, each one painted gray and stamped with USN serial numbers. The men in Peoria worked around the clock, building machines that would never plow a field or grade a road again. While the engineers retooled their factories, the Navy faced another problem: who would operate these machines? Civilian contractors couldn't be sent into combat zones. The Geneva Convention forbade it, but regular sailors weren't trained builders. Moriel proposed a radical solution: create a new branch of the Navy composed of skilled tradesmen, carpenters, welders, plumbers, heavy equipment, operators, men who could fight if necessary, but whose true weapon would be their tools. By December 28, 1941, the first Naval Construction Battalions were authorized. The men called themselves Seabees from the initials C and B. The name stuck. By early 1942, recruitment posters appeared across shipyards and industrial towns. "We build, we fight," the slogan declared. Welders from Pittsburgh, machinists from Detroit, farmers from Iowa, men who had spent their lives moving earth signed up not to fire guns, but to shape battlefields. They trained in Virginia and California, learning how to operate bulldozers, graders, cranes, and dynamite under simulated combat conditions. Instructors taught them how to bulldoze through palm forests, how to lay steel mats for instant airstrips, how to drive a D7 across mud so thick it could swallow a tank. One recruit wrote home, "We learned to build things faster than they can destroy them." In the spring of 1942, the first Seabees boarded ships bound for the Pacific. They were issued rifles and wrenches. The holds of the transport ships were packed, not with ammunition, but with Caterpillar tractors, still covered in factory grease crates, labeled 7-dozer attachments, air cleaner assemblies, extra filters filled the cargo decks. The men joked that they were sailing into battle armed with shovels, but they knew the truth. No army could move without them. Their first test came on a place most of them had never heard of. Guadalcanal, a patch of jungle and swamp that became the hinge of the Pacific War. When the Marines landed in August 1942, they found ground too soft for vehicles and too dense for construction. Within hours, the Seabees went to work cutting trees, dragging stumps, leveling mud with their D7s. The roar of diesel engines echoed through the jungle, drowning the sound of gunfire. The Japanese on the ridges above watched in disbelief. These Americans were building an airfield, while the battle raged around them. By nightfall, the first runway of Henderson Field began to take shape. Bulldozers working under blackout conditions, guided by flashlights and shouted orders. The machines pushed coral sand into piles. Flattening it, layer by layer, the Seabees worked bare-chested under rain that felt like boiling water. Their uniforms, soaked through the air, smelled of oil and wet earth. One Marine officer later wrote, "Those bulldozers were worth more than battalions because, without them, we had no air cover." In Tokyo, a naval intelligence report reached Admiral Yamamoto's desk, describing the rapid construction on Guadalcanal. Japanese analysts estimated that such work should take at least 2 months, yet the Americans had done it in days. Yamamoto underlined one phrase, "construction battalions equipped with mechanical shovels and tractors," he wrote in the margin. This must be investigated further. What the report didn't mention was the sound that haunted every Japanese observer, the relentless metallic growl of the D7 pushing forward no matter the terrain. By the end of 1942, there were over 60,000 Seabees operating across the Pacific. Their machines carving docks into coral reefs, leveling mountains, cutting roads through jungle, and turning swamps into air bases. The bulldozer had become the Navy's most unexpected weapon, a machine that conquered nature itself. January 1943, Peoria, Illinois. The winter wind howled across the frozen Illinois River. But inside the Caterpillar plant, the air was molten. The assembly lines thundered with the sound of riveters and stamping presses throwing sparks high into the rafters. Every few minutes, another yellow steel frame rolled forward, its massive tracks clanking on the concrete floor. The D7 bulldozer was being reborn for war faster than anyone had believed possible. Every station along the line was manned by men and women in denim overalls, welding, drilling, fitting parts in rhythmic precision. One worker could assemble a track chain blindfolded. Another could replace an engine mount in under 2 minutes. Banners hung from the beams reading, "Speed is victory." The plant ran 3 shifts around the clock. The night crews worked by floodlight, their breath hanging in the cold air as they coated the machines with gray naval paint designed to blend with the smoke of the battlefield. On one of those nights, Clarence Peterson walked the line, clipboard in hand, inspecting finished tractors. He paused beside a new D7 idling near the loading dock. Its engine deep and even, he rested his palm against the hood and felt the steady vibration. That vibration, he thought, was what victory would sound like thousands of miles away, because each one of these machines would soon push, coral rock, flatten jungle, and turn nothing into something. He watched as the driver tested the controls. The blade rose and fell smoothly with the hiss of hydraulic fluid. The worker grinned. "Perfect. She'll dig through hell." Peterson smiled. "She probably will." By spring, trainloads of D7S were rolling east and west, their destinations stamped in black ink on the manifests: Pearl Harbor, Espiritu Santo, Guadalcanal, Tarawa, Palau, and dozens of names that had barely existed a year before Caterpillar shipped over 10,000 bulldozers to the armed forces during the war, nearly half of them D7s. But they were only part of the miracle behind the Seabees. The other half was the supply web that kept them moving when General Douglas MacArthur saw Seabees working on the docks at Port Moresby in New Guinea. He reportedly said the only trouble with these men is that they can't stop building even while the enemy shoots. Across the Pacific, the bulldozer was rewriting the map when the Marines landed on Tarawa in November 1943. The lagoon floor was too soft for tanks. Within hours, Seabees had D7s dragging pontoon causeways into place under fire. One operator, Private First Class William O'Brien, was hit twice by shrapnel, but stayed in the seat, pushing debris aside until the first wave of tanks crossed ashore before dying of his wounds. His bulldozer still running idle. His comrades said later, the sound of that idling engine was what kept them moving. The D7 didn't just move Earth, it moved men. Everywhere they went, the Seabees left behind miracles of speed at Espiritu Santo. They built a complete deep-water naval base in just 32 days, docks, warehouses, roads, hospitals, an airfield and housing for 40,000 men at Bougainville. They carved airstrips out of mountains where surveyors had said construction was impossible. One officer said the Seabees were doing to geography what the Marines did to the enemy. They conquered it with steel and sweat. In Washington, Captain Morrell received daily telegrams from the field, his desk piled high with photos of half-built bases and mud-splattered bulldozers. He pinned one photo on the wall, a D7 sitting on a ridge above a coral bay, with the words scrawled on the back, "We build under fire." He showed it to the Secretary of the Navy and said, "This is the symbol of the war, not the battleship, the machine that clears the way for all the others." The Japanese command learned to listen for that sound. 2 captured diaries from island garrisons spoke of the iron monsters that came after the bombardment. One soldier wrote, "The Americans build their airfields, while we are still burying our dead. The sound of those engines is the sound of our defeat." When Seabees landed on Saipan, they bulldozed, wrecked Japanese tanks into the sea to make room for new runways. They leveled villages, bombed into rubble, and used the debris as fill material. Nothing was wasted. Nothing was left standing that could stop a blade. Meanwhile, in California, engineers were improving the D7 further, designing new attachments for specific battlefields, snorkel exhausts to let them wade through waist-deep surf, extended blades for pushing coral slabs, special towing rigs for pontoon barges. Caterpillar sent field engineers with the Seabees to learn from combat conditions. One wrote home, "Our machines are learning faster than we are. They repair themselves with whatever's left. When a track breaks, they forge a new one from scrap metal. When an engine floods, they drain it with coffee tins." In Guam, Seabees rebuilt an entire bulldozer out of parts from 3 wrecks and named it Frankenstein. It ran for 6 more months. By the end of 1943, the Navy counted more than 150,000 Seabees deployed across every theater. The bulldozer had become their emblem, painted on unit signs and carved into plaques. They used it to build runways for B-29 bombers, to dig trenches for hospitals, to raise revetments around fuel dumps, to push crashed planes off airfields, and sometimes to bury the fallen when the shells stopped. The D-7 kept moving its tracks, cutting through silence like a heartbeat. The men joked that when God made the Pacific, He left it rough, so the Seabees would have work to do. In the war rooms of Tokyo, American engineering reports became a grim study. The Japanese Imperial Navy's intelligence analysts concluded that American construction speed outstripped their capacity to destroy what was built. Their shells couldn't keep up with progress. In one captured report, an officer wrote, "The Americans are not fighting for ground. They are manufacturing it." And still, the pace increased by 1944 as the island-hopping campaign surged west. The Seabees moved ahead of the front lines, building airfields within days of landings. Bulldozers often rolled ashore, while Japanese snipers still hid in the trees. At Tinian, 6,000 Seabees built the world's largest bomber base in just over 2 months. 8,500 feet of coral runway, capable of launching the B-29 superfortress that would later end the war. The dozers worked side by side day and night, under the glare of floodlights. Drivers slept in the seats, engines idling. One of them told a reporter, "We build until the fuel runs out, or the world runs flat." Every island followed the same pattern. Destruction, then the low growl of diesel, the smell of oil and salt, the sight of yellow machines crawling through wreckage and mud. Rebuilding civilization one blade at a time. The Pacific was becoming an assembly line of creation, and the D-7 was its beating heart. February 1945. Iwo Jima. The Seabees landed with the 5th Amphibious Corps, their machines coming ashore on pontoon barges during the first week of the assault. The island was little more than volcanic ash and jagged rock, shaped by centuries of eruptions. Bulldozers sank up to their axles in sand hot enough to burn skin. The D-7s had been modified for this. The new track shoes were wider, to spread weight and keep the machines from bogging down. Crews carried spare filters strapped to the fenders to swap out. When the dust clogged the air, intakes operators wore scarves across their faces against the grit. Many of them had been on Guam or Saipan. They knew the job: build the airstrips for the fighters and bombers as soon as possible. The first machine to touch the island rolled off a pontoon at 0930 on February 19th. Its operator, a chief petty officer named Denver Bennett, drove it straight into the volcanic slope, while shells still fell on the beach. A photographer caught the moment later. That picture circulated through the Navy's offices in Washington, captioned, "Bulldozer under fire." Iwo Jima. The statistics were stark. Over the next 5 weeks, Seabees and marine engineers moved more than 800,000 cubic yards of earth and rock, built 3 runways totaling nearly 5 miles in length, and repaired damage nightly under artillery bombardment. By March 4th, the first emergency landing by a B-29 took place on the newly graded strip. A machine flown from Guam with engine trouble that crew survived Because men like Bennett had leveled the ground in time, the D-7s on Iwo Jima wore out faster than anywhere else. Engines running almost continuously, operators replaced blades, welded cracks, and scavenged parts from disabled units. The Caterpillar Company back home received detailed reports of component failures, and redesigns were made in real time. New filters, heavier radiators, and stronger transmission housings shipped out within weeks in the field. Seabees set up their own machine shops, working under canvas roofs with portable lathes to fabricate parts that didn't exist in any catalog on Okinawa. The scale multiplied again, 75,000 Seabees and Army engineers spread across the island, constructing 7 major airfields. 13 smaller strips, 8 naval bases, and over 700 miles of road. In less than 3 months, they used every available machine. 1,500 bulldozers of various models, mostly Caterpillar D7 and D8. The island's coral base made it ideal for runways, but brutal on steel tracks. Mechanics kept repair crews running around the clock, replacing worn shoes and drive sprockets. Caterpillar's field bulletin in May 1945 estimated that a D7 could move roughly 120 cubic yards of coral per hour at full efficiency at Okinawa. They moved more than 20 million cubic yards in total. The logistics of keeping those machines fueled were nearly as complex as combat operations. Each D7 consumed roughly 15 gallons of diesel per hour at peak load, and required 50 gallons of lubricating oil every 100 hours of operation. Navy supply ships carried dedicated cargo of drums marked for engineering units. Fuel dumps near the beach were bombed repeatedly, so Seabees built underground storage tanks out of steel pipe sections buried in coral trenches. One officer called it a refinery without walls. The Seabees methods became standard procedure. Every job began with reconnaissance survey teams marking lines with colored tape, followed by dozers to clear vegetation, then graders and scrapers to smooth the surface. Finally, rollers compacted the coral base. When heavy rains flooded low areas, they drained them with culverts made from 55-gallon drums welded end to end. They built piers, the same way stringing pontoons together to unload more bulldozers. The efficiency was industrial, not cinematic, measured in tons of material per hour, in output per man. As Japan's outer defenses collapsed, the bulldozer appeared everywhere, building radar sites, hospital compounds, depots, and roads on islands with names that had never been printed on American maps. Before Caterpillar's wartime service record listed deployments on 263 separate islands by 1945. The Navy calculated that for every hour of combat, there were roughly 4 hours of construction work behind it, laying the foundation for supplies, aircraft, and reinforcements. The ratio explained why the Seabees motto, "We build, we fight," was not just a slogan but an operational fact. The Japanese referred to them in intercepted messages as the ghost army of engineers. They fought and disappeared, leaving infrastructure where nothing had existed. Their progress reports read like industrial output charts, not military communiques. In 1 week on Leyte, 400,000 square yards of runway paved. In another, on Peleliu, 2 square miles of jungle cleared and drained. 600,000 cubic yards of fill. Laid. The numbers told the story better than any headline. After Okinawa, the bulldozers were prepared for the next step. Operation Downfall. The planned invasion of Japan itself. Warehouses in Guam and Ulithi filled with new D7s waiting to go ashore. When news of the atomic bomb reached the Pacific, most of those machines were already lashed to barges ready for transport. The war ended before they were needed, but their operators understood what they represented. If the invasion had come, those bulldozers would have gone in first, clearing the beaches before the first tanks rolled. By VJ Day, more than 300,000 men had served in the Naval Construction Battalions, supported by nearly 20,000 bulldozers and earth-moving machines. The numbers were unmatched in history. When General Holland Smith, the Marine commander who had fought from Tarawa to Iwo Jima, was asked what made victory possible, he answered without hesitation, "The bulldozer air power couldn't land without it. Ships couldn't unload without it. Armies couldn't move without it." September 1945. The Pacific War ended, but the data kept coming in from every island field. Reports arrived in Peoria from naval officers and engineers. Thousands of pages of maintenance logs, fuel usage charts, and production statistics. Caterpillar's Wartime Research Division assembled them into a document thicker than a phone book, labeled Field Performance D7 Bulldozer Pacific Operations. The numbers were precise and unsentimental. Average lifespan of a wartime D7 before major overhaul 1,850 hours mean time between track replacements, 600 hours blades replaced, every 1,000 operating hours, fuel consumption under heavy load 14.7 gallons per hour. Those figures told the quiet truth behind the headlines. The war had been won not just by heroism, but by measured output and maintenance discipline. The Bureau of Yards and Docks used the same data to draft a report titled Construction Accomplishments in the War Against Japan. Published in 1946, it listed 111 major airfields, 441 piers and wharves, 2,558 miles of road, and 700 million cubic yards of earth, moved most of it by Seabees and their bulldozers. The report's preface stated plainly, the availability of heavy construction machinery and the trained personnel to operate it constituted the decisive factor in every amphibious campaign in the Pacific. Caterpillar's engineers studied the failures as carefully as the successes. The corrosive salt air that ate through radiators led to the development of a new aluminum-bronze alloy still used in marine equipment. Decades later, field modifications to the D7's suspension system inspired the post-war D8 Line 1. Internal memo from 1946 noted operators are improvising tools faster than we can design them, a reference to field welding crews who built blades with additional reinforcements from scrap armor plate. The company formalized those changes into factory specifications. By 1947, the lessons of the war had become engineering standards. For the Navy, the Seabee experience transformed military construction doctrine. Before 1941, field engineering manuals described temporary works in terms of sandbags and lumber. By 1946, they were written like industrial handbooks covering equipment cycles, maintenance intervals, and production rates. The first chapter of the new Manual Navy Civil Engineer Corps' construction battalions included an equation called the earth-moving factor, expressing how many cubic yards a machine could move per gallon of fuel. It was the arithmetic of modern logistics. Universities studied it too at Purdue, and MIT post-war engineering seminars examined Seabee techniques for rapid runway construction using local coral and volcanic ash. The data from Guam and Tinian showed that a properly compacted coral base could bear wheel loads of up to 400 pounds per square inch, nearly equal to concrete. The U.S. Air Force later used those same figures to design temporary bases during the Korean War, and in 1965 at Da Nang. American engineers referred directly to the 1944 Seabee manuals when building jet-capable airfields in Vietnam. The continuity of method spanned continents and decades. For Caterpillar, the war had accelerated the company's growth beyond anything possible in peacetime production, which stood at a few thousand units per year. In 1939, surged to over 50,000 by 1945, factories expanded into new plants in Decatur and San Leandro. Wartime innovations, like modular engine blocks, interchangeable undercarriages, and sealed track pins became standard features of peacetime models. Exports climbed sharply as Reconstruction began. Europe and Asia both needed machines that could move Earth faster than men could plan projects. The same D-7s that had cut airstrips on Saipan were now grading roads in France and clearing debris in Manila. The Seabees themselves shifted from combat to reconstruction duties. By late 1945, they were rebuilding docks in Okinawa, repaving runways in the Philippines, and erecting housing for occupation forces in Japan. The transition was seamless. Their peacetime mission looked identical to their wartime one, only the targets had changed. The bulldozer's roar that once signaled invasion now meant rebuilding. Admiral Ben Morrell wrote in his final wartime report, "The same machines that destroyed obstacles now create foundations for peace." Economists analyzing the mobilization pointed out that the Seabees represented a new model of military efficiency, combining civilian skill with military command structure. One statistic appeared repeatedly in congressional hearings. Each Seabee moved, on average, 1,200 tons of material per month in forward areas. That productivity figure astonished planners accustomed to measuring output in tons of ammunition or barrels of fuel. Construction had become a quantifiable weapon. In 1947, the Navy established the Civil Engineer Corps Officers School at Port Hueneme, California. To preserve those lessons, the curriculum was almost entirely drawn from wartime experience: field logistics, heavy equipment, management, soil, mechanics, under tropical conditions, and combat zone repair methods. Caterpillar engineers lectured alongside naval officers. The line between civilian and military engineering had nearly vanished. Port Hueneme became the permanent home of the Seabees and remains so today. Statistically, the bulldozer's wartime record was unmatched: over 20,000 units deployed, 17,000 returning after service, thousands rebuilt and resold under Lend-Lease programs to allied nations including Britain, Australia, and China. Caterpillar's post-war service logs traced individual machines that had crossed the Pacific 3 or 4 times during the war. One D-7 shipped in 1942 to New Caledonia, later worked on Espiritu Santo, then Guadalcanal, then Okinawa, before being returned to California for overhaul. In 1946, the total recorded hours on its engine exceeded 5,000 more than double design expectancy, yet it still functioned. In the broader field of engineering, the war had proved a principle that extended beyond machines. Adaptability under pressure was more valuable than precision design. When Donald Bailey's bridge and the Seabees bulldozer met in the same theater, they produced a pattern of rapid infrastructure that modern logistics still imitates. Today, pipelines, ports, roads, and runways, built as modular units assembled by small crews with standardized tools. The Pacific War was a laboratory for the industrial methods that would rebuild the post-war world. By 1948, the Seabees were officially folded into the Navy's permanent structure, and their wartime bulldozers were being shipped to reconstruction projects from Okinawa to Panama. The Caterpillar D-7 had become more than a wartime relic. It was the baseline machine for a new branch of military engineering called rapid deployment construction. When the Korean War began in 1950, Seabee detachments and Army engineers again used the same methods from the Pacific Islands. Within weeks, they had airstrips operating at Busan and Incheon. The same coral and volcanic soil techniques now applied to frozen Korean ground. Navy logistics reports from that year show that roughly 60% of all heavy equipment used in the first 6 months of the conflict was rebuilt. World War II stock, most of it D7 and D8 tractors, reconditioned with newer diesel engines. At the same time, the civilian world adopted the same technology under the U.S. Army Corps of Engineers' direction. Bulldozers became the primary tool for the Marshall Plan reconstruction in Europe. Caterpillar opened offices in London, Paris, and Rome, selling hundreds of war-surplus tractors to governments rebuilding bombed infrastructure. European engineers studied Seabees manuals for guidance on rapid road and bridge repair. One French report from 1949 credited American naval construction practices with reducing bridge repair times by 70% in flood control projects. The British Royal Engineers standardized equipment compatibility using the D7 track and blade design as the industry template. By 1952, Caterpillar's machines were operating in 172 countries, nearly tripling their pre-war reach. Back in the United States, many former Seabees continued their trade in civilian life. A 1951 survey by the Bureau of Labor Statistics found that almost 40% of heavy equipment operators in post-war construction were veterans of the battalions they carried the discipline and field knowledge learned on Coral Islands into peacetime industry. The Interstate Highway Program that began in the 1950s owed much of its early workforce to those men. They understood how to organize crews for continuous 24-hour operation, how to maintain machines in harsh environments, and how to treat every job like a supply chain rather than a static project. Caterpillar's production numbers reflected the transition. By 1953, over 100,000 D7 and D8 tractors were in operation worldwide. The company's research division continued to use wartime data in new designs, experimenting with torque converters and hydraulic controls to replace manual clutch systems. Many of these innovations came directly from suggestions written in grease pencil. On shipping crates by Seabees, in 1944, field improvisations became patents. In the post-war years, one internal engineering memo from 1950 summarized it bluntly. "The battlefield is the best proving ground we will ever have." The Seabees themselves evolved into a global force for emergency response during the Cold War. They built radar stations across the Arctic. The distant early warning line in Alaska and Canada relied on modified D7s fitted with cab heaters and extended track guards to operate in sub-zero temperatures. In the 1960s, the same organization constructed bases in Vietnam airfields, hospitals, and roads using upgraded D8H and D9 tractors. But the process remained identical to that developed in the Pacific in 1942, standardized modular construction, small teams of trained operators, and a logistical pipeline that treated earth-moving as the first phase of any operation. For military historians, the numbers tell a simple story. By the end of World War II, U.S. Navy construction forces had moved roughly 1.2 billion cubic yards of material, enough to fill the Panama Canal, 4 times the average productivity per man-hour, doubled between 1942 and 1945. And the mechanical reliability of Caterpillar machines exceeded 90% in continuous field use compared to 60% for earlier models. Those figures explain why the bulldozer earned the reputation as the fifth arm of the Navy, and why other nations copied the model. Britain's Royal Engineers developed their own construction units based on Seabees organization. The Soviet Union produced a near clone of the D7 designated S-80 for similar tasks in Siberia. In academic circles, the bulldozer's wartime record became a foundation for studying systems engineering. Before the term existed, the coordination between design factories, shipping logistics, field repair, and operator training represented a closed industrial loop decades ahead of its time. Modern supply chain theory and lean manufacturing often cite Seabee construction as an early large-scale example of adaptive production management. The principle was simple: measure everything, build faster, improve immediately. By the 1970s, the Navy published a centennial history of the construction battalions, noting that over 160,000 Seabees had served since World War II. On projects in 111 countries, their machines had become symbols of stability, appearing in disaster zones more often than battlefields. In 1976, when a typhoon struck Guam, Seabees cleared 400 miles of roadway in 5 days, using bulldozers descended directly from the wartime D-7. The same machines that had once built runways under fire now opened roads for relief convoys. For Caterpillar, the legacy was permanent. The company's engineers often referred to the D-7 as the machine that proved itself under fire. Production continued through multiple variants, D-7C, D-7E, D-7H, each bearing improvements drawn from wartime field reports. The machine remained in service in both military and civilian roles. For decades, the United States Department of Defense kept a fleet of Caterpillar tractors in readiness through the 1990s in Seabee units deployed to the Persian Gulf, where they again cleared sand berms and built temporary bases. The sound and function were unchanged, only the geography had shifted. Today, historians looking at the war's industrial side frequently cite 3 inventions as defining Allied logistics: the Liberty ship, the Bailey Bridge, and the Caterpillar bulldozer. Each embodied the same engineering philosophy: modular, repairable, and fast in production. Each allowed the United States to convert industrial capacity into direct battlefield advantage without requiring new technology. Only new organization. The bulldozer's part of that triad is often overlooked because it lacked glamour, but its measurable output was unmatched. 75 years after the first Seabees landed on Guadalcanal, a few of those original bulldozers still exist, preserved in museums and on naval bases in California and Hawaii. Their paint faded, their blades pitted with rust, but the serial plates still legible. The D-7 designation stamped in steel when visitors ask curators why the Navy preserved a simple tractor. The answer is usually factual, not sentimental, because without these machines, nothing else would have been built. The records prove it. The bulldozer that built the Pacific was not a metaphor. It was a measurable fact. Tons of coral moved per day, cubic yards graded per hours of flight time gained by each runway. It remains one of the clearest demonstrations in history that engineering and logistics, not firepower, decide the outcome of modern wars, and that men with wrenches and diesel fuel can alter the course of nations. Thanks for listening till the end. I put a lot of effort to bring you factually correct and lesser-known stories of the past. Subscribe my channel if you like this type of content.